Hi everyone, this is a bit of an easier one. We're looking at algebraic naming conventions, which is pretty low level, but it's very hard to do the more difficult exercises until we have a grasp of these naming conventions. So let's get started. So modeling a situation with algebra that anyone can understand means that we have to do all the work the same way. So this means that everyone needs to use the same conventions so that we can all read them and work with them the same way. So in the last video, we found that algebra doesn't tend to use multiplication and division symbols, and that we use letters to represent unknown quantities. So that's summarized here. X times 2 we usually write as 2x. X divided by 2 we'll write as x on 2, and 2 divided by x we'll write as 2 on x. And we emphasized that order was important. Now, when we describe relationships between unknowns, we use expressions and equations. Now, an equation is in this form here. It has a left-hand side, LHS, and a right-hand side, RHS. And this is called an expression, and this is called an expression. And then on either side of an equal sign, when we have an expression equals another expression, we call that an equation. So within an equation, we'll typically have some expressions. So there's one there and one here. And inside the expressions, we'll have terms. In here, in case you have a term of 4x and one of -7 and another one of 5. Now, with that in mind, the number in front of x we call a coefficient. So if we have a variable and a number immediately before it, the number is called a coefficient, the letter is called a variable. The sign between different terms is called an operator. So here's a term, here's a term. And if a term doesn't have a variable, we call it a constant. So that's a whole heap of information that we're going to use over and over again for the next 10 minutes or so. Now, there's a couple of additional implied conventions. For one, if there's no coefficient written in front of a variable, the coefficient's 1. Unless, of course, the sign is negative, and then it would be -1. So in this case here, with this equation 2 take x equals 5, the coefficient of negative x, the coefficient of x, I should say, is -1. In the case of x plus 2 equals 5, the coefficient of x in this case is just +1. So we need to take into account the sign and the fact there's nothing there, which is just a 1. Now, when we have brackets, and later we'll work with fractions and indices, they may also create terms comprised of expressions. So in this case, we have 3 plus x take 5 equals 10. We think of this as having 3 terms, 3, x take 5, and 10. The second term, x take 5, is comprised, funnily enough, of 2 terms, x and -5. Now, if we think about it this way, it makes rearranging easier later, and it makes the rules that we need to use make sense. It's not always done this way, but we're going to look at it from that perspective. Sort of goes against what I was saying earlier about everyone doing the same thing, but well, maths is maths. Note that what separates terms typically is plus and minus. So that plus is what makes these two things a term. That's a term separated by minus, that's a term. We have this equal sign, that's also a term. And the same with these. Okay, now, if we can use those words successfully and work with our expressions and equations, we'll be able to do the sorts of work that's required to solve problems. So let's look at that in some detail. If we have 2y take 3y take 5 equals 0, the left-hand side expression is this part here. And that's what I've written there, hopefully. And the right-hand side expression is just 0. The terms in the equation are 2y, -3x, -5, and 0. The constants in this expression are -5 and 0 because neither of them have a variable. The variables in this equation are y and x. There they are there. The coefficient of x, here's x, is -3. That's the number in front of x. And the coefficient of y is 2. So far, so good. Now, here we are with another one. We have another equation. The equation is that. The left-hand side is this. The right-hand side is this. So put the left-hand side in the left-hand side expression box. 5y minus 4 goes in the right-hand side expression box. The terms are -5, 2x, 5y, and -4. The constants are -4 and -5. The variables are x and y. The coefficients of x, the coefficient of x is +2, and the coefficient of y is 5. Looking at the next one, we have x take y equals -15. The left-hand side expression is x take y. The right-hand side expression is -15. The terms are x, -y, and -15. The constant in this case is just -15. These both are variables. The variables are x and y. The coefficient of x is 1. The coefficient of y is -1. And last but not least, this expression we looked at last time, the left-hand side expression is p. The right-hand side expression is 3n take 25 plus n, with brackets around 25 plus n. The constants, so that would mean the terms in this case are p, 3n, and 25 plus 2n. It has no constants because we can't count 25 because that's part of a term. There has no coefficients of x, so there's no x's in it, and no coefficients of y because there's no y's in it. And now we can look at doing that for some other examples. I'll get my pen out so that I can work at this. Let's use a black pen. I'll use a blue pen. Okay, now I might use a black pen. If we have 4x take 12, 4 is a coefficient. It's the number in front of a variable. X is a variable. And 12, or -12, is a constant. A plus 3b. A is a variable. 3 is a coefficient. And b is a variable. 6y, 6 is a coefficient. And y is a variable. So, as I was saying, this isn't a particularly hard exercise, but we do need to be able to recognize that, what it is we're looking at so that we can describe it and then work with it. So I hope that was helpful, and I look forward to seeing you in the next one. Thank you. Bye.